Hi there. Today I wanted to walk you through how Tidal Accelerator's instance recommendation works when conducting an AWS OMA, or Optimization and Modernization assessment. I'll walk you through what a typical OMA workspace might look like and how you can generate your cloud instance recommendations, including for instances with Graviton processes. Let's take a look. Here is a workspace where we've completed the discovery phase. We have 10 apps on 40 servers. We've done application owner interviews. And for servers, we've captured all the technical data we need to generate our cloud instance recommendations. You can do this by uploading your Excel spreadsheets or by scanning the infrastructure directly using Tidal tools. So we've organized these apps and servers into a project called Optimization and Modernization Assessment, broken down into migration waves. Migration waves are groups of resources which make logical sense to migrate together. So for this project, we're doing 4 migration waves. To get an instance recommendation for a server, we need the relevant data for that server, and we need the server to be in a migration wave. In this workspace, we have one server which doesn't have a recommendation. I left it out so that I can demo it for you. While we're here, I wanted to point out how you can adjust the servers page to help you identify which server needs more data and tweak this page based on what you're trying to do. So this table is all of the servers in the workspace. We can customize the columns here. And what we'll do is we'll adjust this table so it shows all the data points we need for cloud instance recommendations. So we'll get rid of fully qualified domain name. First thing we'll need is CPU name. We'll also need CPU logical processors. And we need those so that we can estimate the compute power of the server. We also need information about RAM, with the very least RAM allocate. If you also have the amount of RAM that the server is actually using for its workload, then we'll prioritize that over RAM allocated so that we don't over-provision your server in the cloud. And just so that we have visibility, we'll also include cloud instance targets. This first server doesn't have a cloud instance target yet, and that's because it's missing a crucial piece of information that we need, which is CPU name. So let's navigate into this server record so that we can fix it up. So if you're looking at a server that doesn't have a cloud instance recommendation yet, we've actually got a handy tooltip here that gives you some hints as to why. We need to know the name of the CPU. The reason we need this is because if we know what the CPU is and how many logical processors it has access to, then under the hood we can generate an estimate of the compute power of the server. We can then recommend the most cost-effective cloud instance with the equivalent compute power in the cloud. Of course, if you're also able to give us CPU utilization data using Tidal tools, then we can make more accurate recommendations based on the actual compute power utilization of the server. This isn't strictly necessary though. If you don't provide utilization data, we assume that it's using 100% of the available compute power to avoid under-provisioning in the cloud. In this scenario, we recommend that you perform further optimizations in the cloud once you have a few weeks or months of application performance metrics. Now let's sort out our missing data. You can discover your server's CPU name by scanning the server with Tidal tools, but if you already know it, you can enter it manually. Let's say this server is running an Intel Core i5. We'll choose i5 4430. As you can see, that's the last detail needed to generate our cloud instance recommendation, so it's triggered one automatically. Great, so we've been recommended an R7G.large cloud instance. This particular instance is running a Graviton 3 processor. These can be up to 45% cheaper than the equivalent Intel instance with similar specs. Now, as I mentioned, this project has about 40 servers in it, which means 40 cloud instance targets. To see these, navigate to the parent project, click on Optimization and Modernization Assessment, which is the name of the project. And then you'll see here we have a tab for instance targets. Now, this will show us all of the cloud instance targets for the project. The vast majority here have been recommended instances running Graviton CPUs. Graviton CPUs are generally the most cost-effective for their compute power. So in this video, we've taken a look at what a typical AWS OMA workspace might look like, and we've seen how we can generate cloud instance targets for our servers, including instances running Graviton CPUs.
Visit Tidal.cloud.com to explore doing a no-cost OMA analysis with Tidal Accelerator and sign up now.